Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a water bottle which is made of PET material for the static structural analysis. Here we are going to test the bottle for an external crushing pressure which will be exerted on it. So we will start by double clicking on the static structural module. We will first go to engineering data and double click. Here we are going to add the material PET. We will give the value of density which is 1380 kg per meter cube. Also we will give the value of isotropic elasticity. Young's modulus in megapascal is 4000 and the value of Poisson's ratio is 0.39. We will go to project and update project. Next we will go to geometry. Here I will directly import the geometry which is made with me. I'll give you the link for the geometry such that you can download and use it for the analysis purpose. We will go to model now and double click. We'll first go to geometry. Here you can see there are two parts. This is the cap and this is the bottle. Now I don't need the cap, so I'm going to suppress this body. We'll go to the next one. We'll change the material to PET. Then we'll go to mesh and we will generate the mesh. You can change the sizing of this mesh. I am keeping it to default size itself. Here you can see tetrahedron mesh has been formed and the mesh is of a decent size, which is the default mesh which I have generated. Next we'll go to static structural. Here I'll right click and insert fixed support first. At the bottom end I'm going to give the fixed support to all the 5 edges here and apply. Next I am going to insert pressure which is on this cylindrical surface. Apply. This value of pressure I'm going to give as 1 megapascal. Next we'll go to solution and right click and insert deformation total. I also want to see the deformation directional which is along the x-axis or along the z-axis, as you can see, because this is radial body, so you can use any one axis. Next I'll go to insert strain equivalent. I also want to see the stress equivalent. Now there is one more value which if you want you can see, which is the deformation directional along the y-axis. Next I'll go to solution and solve. Let's see the result for total deformation. The maximum value is 0.93315 mm in this zone, as you can see. Minimum is 0. You can animate and check this result. So you can see when you compress the body in the central position, the body gets elongated. So this is a kind of crushing effect on the bottle, you can say. Next is the directional deformation along the x-axis. The value is 0.73 mm maximum and minimum is minus 0.72. So you can just go to edges and remove the wireframe such that you are able to see the bottle very clearly. If you animate, you will get the same pattern of motion, but only you can see over here how the value of directional deformation is changing over this body. Next, we will go to equivalent strain. The maximum strain is 0.03629, where you cannot see directly, so we can just go to max min. So here you can see this is the maximum value and minimum is over here. Minimum value, as you can see, is 1.248 into 10 raised to minus 5. Then we go for the stress value. Maximum stress is 137.71 megapascal. Now, when you have a PET material, the tensile strength maximum is 205 megapascal and the compressive strength is 60 megapascal. So as you can see over here, this is the direction of elongation and here is the direction of compression. So in this zone where you can see there is elongation, the value is known and maximum is over here. It is 137.71 megapascal. So it seems that the bottle would have crushed actually and it would have deformed permanently because this value of stress is quite high in this central zone and here it is lower. So this will have sustained but this will not. But since we are just using static structure analysis, this is maximum that you can see. We will be taking up explicit dynamics also such that we will see how the crushing is taking place. Currently we are only seeing the static part of it. Then comes the directional deformation along the y-axis if you want to note down that value. So that also can be done and here you get the maximum value as 0.811 mm at this zone. Minimum is here because it was fixed. So as you can see, the value of deformation is actually changing from here to here or from here to here, whichever direction you read it, you can see difference in the value. Now, if you suddenly stop, this will also halt. So what you can do is just go to stress and come back to deformation again. You will be able to see these colors. What you see over here is perfect bands. If you don't want that, you can go to contour and select smooth contour such that the colors blend into each other. Now that is your choice how you want to show your result. If you don't want to see this max min, just click on max min once again such that it disappears. If you want to find the value at a particular position, take the probe option, go to that position, click over there, you will get the value at that node. You can see here these are the node numbering. So these are the nodes at which you are getting these values. If you don't want these values, you can right click here and delete all. So that's how you analyze the water bottle which is made of PET for its static structure analysis. Now you can change the material to HDPE or say some other plastic material and you can do the same type of analysis. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.